Hello all, I'm Naren from School of Chemical and Biotechnology SASTRA, and this video is part of the Fluid Mechanics for Process Engineers course. We are on the learning Capsule 11.2 of the module 11, and we are discussing on the non-Newtonian fluids. These are the suggested readings for this capsule. Now we have seen in the earlier capsule that there are fluids which can be classified as non-Newtonian because they do not follow. So they do not follow the functional relations of shear stress equal to the viscosity times the shear rate. Now, before going into the mathematical form, let me just take two examples of such a fluid and explain you how the behavior is. One is a paint. Now, what is your observation when we apply paint? Apply paint through a brush, right? Now, you might have noticed here that as you apply, so when you say as you spread with the help of your brush, so this is an indication that you are applying the shear stress on the fluid. You can see that the deformation or the paint spreads. The paint spreads on the surface, right? There is more spreading of the paint on the surface, so which means that the response, right, increases as you increase the shear stress, and this proportionality, and this does not is proportional necessarily to the shear stress that you applied. That at the beginning maybe the spreading is very less, but as you apply more and more pressure on the brush to spread the paint, you will see that it becomes really thin and it gets spread. So this is one kind of a system where the fluid acts as if it is getting thinned and becomes easier to move, or I would say the motion is getting facilitated with increase in the shear stress. Let's take another example. This is of a cornstarch. Now you can actually pause this video and go back to YouTube and also see the video with the name oblak kind of fluid system. Now this oblak is actually a suspension of starch in water, cornstarch in water typically, and you would be noticed that this is like a kind of a magic fluid what people propose, that you will be able to walk on this fluid, but there is a caution: you need to walk fast. Okay, so if you walk slow, you will literally fall, because you are walking on the fluid and obviously you're going to fall on the fluid system. Now what is the observation based on this? How do you explain this observation? Now when you walk fast, so that means when the walking fast increases, the shear rate is enhanced, so that means there is very high shear being applied. And when the shear rate is enhanced, it becomes as though it is a solid. It resists, it is able to support the weight of the person who is walking on that. So that means it looks as though it is becoming solid. So it becoming solid, it means like its viscosity increases enormously, right? So as long as the rate of deformation is very high, right, its viscosity increases enormously and it is able to support the weight. Whereas for a person who is walking slowly, this is still a fluid, so that means this weight cannot be supported and eventually the man falls down or the object falls down. So these are the two typical examples that one can see to find out how a non-Newtonian fluid behaves. Now, what about the toothpaste that I talked about in my earlier video? Now, you can see that if you press until a certain point, okay, is reached, or you would observe that you might have pressed it for a minute, you might have pressed it, applied a given force, you will not see no visible paste coming out of the tube. But a moment some threshold is reached, you will see that the paste actually flows out of your tube, okay, without any more stress being applied, without any more force being applied on the tube. This is a common observation everybody would have had in our homes. So based on these observations, and what you can also see are similar observations in other kinds of fluids, the non-Newtonian fluids are classified predominantly as non-Newtonian fluids can be classified predominantly as Bingham plastic, right? You can have as a shear thinning fluid. So this is what is of paint, and a shear thickening fluid. A shear thickening fluid is a cornstarch water powder mixture which I talked about. This is also called dilatant. This is also called as pseudoplastic. I would pause the video here and I'll go back, and I request you to look for other examples of Bingham plastic, pseudoplastic and dilatant. And these are not the only types of fluids, the non-Newtonian fluids that we have. We also have other types of non-Newtonian fluids such as Casson fluid, and we also have something called thixotropic fluid and rheopectic fluid, and so other varieties. I would expect that you will go back and look into what are the examples of this, and in our next learning capsule I will take on the mathematical expression that is typically used to describe the non-Newtonian fluid. Thanks for watching this video.